Hello there! Have you ever wondered how wireless charging works on mobile phones and electric cars? Well, I guess you've come to the right place. Here I am to present you the topic on wireless power transmission. I'm ZCA from G40, your first presenter, and my subsequent presenters are Ping Qingler and Luo Xueqi. So, I think we're all set. Let's go! Before we start on anything, we shall first ask ourselves what is meant by wireless power transmission. So wireless power transmission, or known as WPT for short, is a transmission of electrical energy without using wires as a physical link, and it is a general term of a number of different technologies, which means it generalizes a few different technologies that transmits electrical power by means of electromagnetic fields. So as you can see on the screen here, we have a general setup of the WPT system. Mentioned just now, there are a few different types of technologies that can be grouped together and known as WPT. So here we are to see the different types of WPT technologies. So those technologies are grouped into two groups, depending on their operating field regions. The first one shall be the near field and the other will be the far field. So the near field region utilizes inductive coupling, capacitive coupling, and magnetodynamic coupling, while for the far field, they use microwaves and lasers. Here on the screen, we have two different diagrams, which are examples of capacitive and inductive coupling. The top one being the capacitive coupling, while the below refers to the inductive coupling. So here I'm going to give you a brief background history on WPT. So WPT, the development involves two key persons. The first one shall be Michael Faraday in 1831. So Michael Faraday, he demonstrated and discovered the principle of electromagnetic induction, while in 1894, the inventor Nikola Tesla has actually applied Faraday's idea and demonstrated the phenomenon of resonant inductive coupling. So from now on, I shall pass my duty to Qingler to explain the following information. Thank you.
Hi, I'm Qingler. So now let me explain to you about how wireless power charging actually works. Firstly is inductive coupling power transmission. Second is the microwave power transmission. And thirdly, the laser power transmission. Inductive coupling power transmission. This will start with a transmitter part and also the receiver part. So at the transmitter part, you will need an AC source. The AC source will supply current to the transmitting coil, while when the current flows in the transmitting coil, a magnetic field will be formed around the transmitting coil, where when the receiver coil is put near to the transmitting coil, this will produce a magnetic flux. This follows the law of Faraday for electromagnetic induction. So, when the magnetic flux is produced, this will supply a voltage to the receiver. So, at the receiver, the generator voltage will be rectified, filtered, and regulated to get a proper DC voltage at the end of the devices. This usually works well for short-distance power charging like electric toothbrush or mobile phones. So what about great-distance power charging like for electric car? For great-distance power charging, capacitor will be added at the transmitter coil part and also the receiver coil part. So, when an appropriate capacitance is added, the loops will resonate at the same frequency and the amount of induced current in the receivers will increase. This is called the resonant inductive charging or magnetic resonance. Resonance inductive charging enables power transmission at greater distance between transmitter and receiver. This could also increase the efficiency of power charging. Transmission, it is also divided to two parts, the transmitter part and also the receiver part. So, at the transmitter section, the microwave power source will generate a microwave power which is controlled by the electronic circuit control circuits. The tuner contests the impedance between the microwave source and transmitting antenna. Based on the signal propagation direction, the attenuate signal are separated by the directional coupler. So the transmitting antenna will then emit the power regularly through free space to the receiving antenna. So the receiving antenna will receive the power and the power will be controlled and filtered so that it can supply suitable power to the For laser power transmission, laser is used to transfer power in the form of light energy and the power is then converted to electric energy at the receiver end. The laser gets power using different sources like sun, electricity generator, or high-intensity focus light. The size and shape of the beam are decided by a set of optics. The transmitted laser light is received by a photovoltaic cell that converts the light into electrical signals. Usually, this is used using optical fiber cables for the transmission to happen in more efficient way. Now, let us take a look at the application of wireless power transmission.
Hi everyone, my name is Xie. So I'm going to share with you about the applications of wireless power transmission. So before we know how wireless charging works, we must understand the meaning of wireless charging standards. Standard means that different set of operating system in which with different devices are compatible with. So there are two major the standard, which is G and PMA. Although they work in a similar way, but they have different transmissions frequency and also portable connection portable. So this is okay. So different devices are compatible with different standards. But there are also devices which are compatible to both standards. So this is the wireless charging board, and this is the charging panel, which is wireless charging panel, which is introduced by IKEA. Okay, so in fact, Qi standard was introduced by Wireless Power Consortium. This standard uses inductive charging over distance up to 4 cm. The system uses a charging pad and also a compatible device. The compatible device will be placed on the charging pad and the charging take place due to resonant inductive coupling. So in 2008, Qi standard was introduced and the system is used in many devices, for example, smartphone, tablets, and the most popular devices are Apple, Google, Asus, Huawei, and also Samsung. So this is the Qi symbol, and this is the devices using Qi standards, and this is the AirPod, which is introduced by Apple, which also uses Qi standards. Already explained the working principle and theory in detail just now. I will say it in a simply way with a picture. So at first, when the power supply to the charging base is switched on, AC flows through it. AC currents will produce an electromagnetic field, or we call as alternating magnetic field, around the primary coil. When the secondary coil, or we call receiver coil, that housed in this smartphone come in contact with the alternating magnetic field, an electric current is induced in secondary coil. Okay, so the AC flowing through the coil in the smartphone is converted into this DC current by the receiver coil, and this DC current is used to charge up the smartphone. Wireless charging normally divided into two categories, low power and high power. Low power application usually work for small consumer electronic device such as smartphone, laptops, and other devices that charge up to a power level below 100 watts. While for high power application, normally it works for devices that charge up to a power level above 1 kilowatt, for example, electric vehicles. So this is the example. For example, electric vehicles that using charging pad, then laptop also using wireless charging pad, and nowadays there are 50 types of electric vehicles that uses wireless charging. Since the 1990s, the Braun company has introduced Oral-B rechargeable toothbrush, which also using wireless charging. So this is the Oral-B rechargeable toothbrush. And since 2008 until today, smartphone, laptops, electric vehicles, and other kitchen appliances are also using wireless charging. A majority of smartphone manufacturers such as Samsung and Apple has adopted the Qi wireless charging standard. So the idea given out by the Samsung today is the surface charging, which active charging station is built into the entire surface, for example, desk. And the idea given by Apple is we call dock-based charging platform, which induce a charging pad and the disc, which is smaller in size. Wireless charging is also used in other fields. For example, in medical field, researchers are trying to charge the implants and sensors which are long-term situated under the patient's skin. And these under-skin devices, which are aimed to monitor the patient's status, could have a longer term life and also a longer observation or monitoring periods for the doctor to have a better diagnosis. This is the wireless charging for medical field, and this is the wireless charging highway, which is currently introduced in Sweden. Okay, so Sweden opened first electrified road in 2008, a 1.2 mile road between the Stockholm Arlanda airport and a logistics site is built, and this road is used to charge the cars and lorries that travels along it. Okay, so there are many obstacles in developing the remarkable wireless charging. The major obstacle is achieving higher efficiency. So researchers from North Carolina State University and Carnegie Mellon University shows that passing wireless power transmission through a magnetic resonance field enhancer, or we call MRFE, which can be as simple as a copper loop, can boost the transfer efficiency by at least 100% by compared to transferring the power through the air alone. So the MRFE can be 5 times more efficient than the use of metamaterial. This is the metamaterial, and 50% more efficient than transfer the power through the air alone. So this is the air. So also the MRFE amplifies the magnetic field by removing a little power from the system. In conclusion, wireless charging is a potential technology that do improve our mobility. So before I end my presentation, I hope that we arouse your curiosity in the field of wireless power transmission and also wireless charging. We do hope that you will be inspired by this technology and make an impact out of it. Thank you.